Data Infrastructure, NFDI, Nationale Forschungsdateninfrastruktur. And we are embedded in this big network of the NFDI. So I just spot a few of the consortia here that are somehow related to us in material science or in natural science in general. But of course, we also collaborate with others, like PUNCH is the consortium for astrophysics, MADI, the consortium for mathematics and things like that. But of course, we not only live in Germany, we are an international endeavor. So we have a lot of connections to EU projects and to EU initiatives. And of course, also worldwide. For instance, the NIST in the USA is a collaborative partner, and also connections to China, Korea, and so on. So what do? We are a consortium of about 6 TPIs, and this is taken from the proposal. That means a few people have been exchanged, but overall it's the structure like this. We have collected about 60 renowned scientists from all over Germany that represent one or the other subfield of materials science or of condensed matter physics. So how are we organized? As you see, you also see it in our webpage, but you will also see it from the different contributions that we'll have later on. We're organized in terms of areas. And we have areas in terms of synthesis. Area B is dealing with experiment. Area C is about theory and computations. And for all these 3 areas, we built the digital infrastructure. We have use case demonstrators from the various fields. We reach out to the community like we do, for instance, today. And then, of course, someone has to take care about administration and the budget and things like that. The most boring things, but it's exciting. If you want to read more about our strategy, you're invited to look up this paper that appeared quite recently in Nature, and all the area leaders are authors of these papers. Now, if you're interested in our history, or if you're interested, so to say, where we come from and what we're doing, it's always good to look back a few years from now or into the history. So actually, the first repository that we built was a bilateral project by Matthias Schäffler from the Fritz Haber Institute and myself. It was a project on thermoelectric materials where we wanted to fulfill 2 purposes. So one is that we wanted to have an eye already on artificial intelligence at this time. This was 2011 or 12 when we started. But we also wanted to collect the data of the groups in order to be sustainable. So not to search for the data on the computer of students who left already 2 or 3 years ago. So, but at that point, or quite early, we found out that it was so it's also convenient, so practical to have this database that we opened it up, and this was beginning of 2014 already, such that now we collect, or in the collection we have, I think, 1.4 million, Markus, you may correct me, what the total number is, of calculations inside this database. And this happened during the last 10 years. It's contributed by a few hundred individual researchers, but we also have collaborations with the big American databases like Matthias Project, EFLO, and OQMD, who provide the raw data to us. And if you want to have the raw data from these materials databases, you can do it through NOMAD. So, but this was just a very early start. Then out of this bilateral project, there was a EU project following, and this was a European Center of Excellence from 2015 to 2019. It was an effort of 13 research groups and also compute centers. And this was actually the starting point for all the services that we were providing. Yeah, so this was 2015 to 18, sorry. So, and the NOMAD Center of Excellence, there's a new edition now, so not to be confused, I just want to tell all the terms to disentangle things. So there's another NOMAD Center of Excellence that runs from 2020 and 2024. It's all about exascale computing, so exascale code, exascale workflows, and extreme data. And this is actually not in the focus of today. I just wanted to mention, just in case you're asking the question, what all these NOMAD family members are, right? So let's go to what we're talking about today, and this is the services that we started already a few years ago. So this NOMAD Laboratory, which is also published in MRS Bulletin 2018, I don't know what this is doing, is a forerunner of a FAIR database. And why is this FAIR? Let's start with the F. F means findable, because of course, if you upload data to a repository, then this data can be found. So there's no miracle about this. So if you upload data, then you also can download data. So in that sense, data are also accessible, which is the A in FAIR. But we wanted to have something different, because if you just download raw data, which are input and output files of a calculation, for instance, people wouldn't have fun with this. So an experimentalist wouldn't like to go through your output file and look for energies or band structures and things like that. That's why we came up with the NOMAD Encyclopedia, which is kind of a visual representation of all the data that are produced by the community. So at that time, it was just theory and calculations. Now we're expanding, and this is what I'm going to talk about in a second from now. Now, what about the I, the interoperability in FAIR? In order to make sure that data are interoperable, that means that you can bring together data from different sources, we had to write parsers. And converters. So what you see here is the community codes. So there are about 40 or 50 such codes that are produced by the community, that are used by the community for running calculations. And we had to make sure that all these data are annotated and they are normalized, in the sense that we bring all this to the same file format, to the same units, such that everything is represented in the same way. And this is what the archive is about. And then based on this archive, of course, we can operate with this data with machine learning, artificial intelligence tools. And this AI toolkit is a first collection of such samples that show you how you can work with the data in order to explore new things or analyze your data properly. So in that sense, this is history, so to say, that happened until 2018 or 19 or something like that. But this was somehow a good starting point, a building block for what we're doing now in FAIRmat. And of course, this R now stands for reusable. I mean, artificial intelligence is a very nice example for how you can make use of data that have been produced in a different context. So what are the benefits? Of course, sustainability for me is something very important, because we throw away too much stuff, not only in real life today, but also we have to make our research sustainable. So in that sense, we should avoid doubling of work. So if someone has carried out a very complex calculation or measured something, why not providing this data to someone else? Because everything would need to be done otherwise from scratch. So in that sense, you can save computing power, you can save energy, you can save personnel power, because these people can do something else or focus on something else which has not been explored so far. So getting organized is another very practical thing, to be honest. Reproducibility is also another thing. So if a student wants to measure something or compute something, probably these people can go to the database and see what is already available, what is there, and then can compare if you get the same result or not, and why it may be different. And visibility. So I think there is, well, there was some people were afraid, why should I give away my data? I think this has changed in the community, because now people realize if they provide data, this data can get cited. And so, for instance, well, you also can get a DOI for the data to make it cited, and then you can add this DOI to the publication or whatever you do. So for instance, if you just take an example from my own publication list, there you see this is the DOI to the paper, this may be the archive, and wherever you go alongside this publication, there's the DOI to the data, so you can click there and you get immediately the database, and this DOI or this link is also provided in the publication itself. So, and see, in the publication, it then looks like this. So now let's get back to what we're doing in real life. So NFTI consortium FAIRmat. So what we're doing, we are building on what I've shown you before. So we are further developing we're extending towards experiment and synthesis And we're also we're operating this infrastructure. And this is the reason why NOMAD has become a brand. We still use this brand name. So whatever FAIRmat develops, we still publish somehow under the brand name, because we didn't want to take it from the market, so to say, and come up with something new, because this has been established for 10 years and we simply use the name again. So FAIRmat is operating the NOMAD Laboratory, if you wanted to ask this question. So what are we doing? So FAIRmat is an inclusive and user-driven approach. This is extremely important to us, because only the people who work with the data, who know what the data means, and we cannot just outsource all these activities to librarians, because we would need to explain anyway what the meaning of the data is. So, and what we're doing is we provide an infrastructure, turf, fair data processing, storage, curation, sharing, AI readiness. Well, this is in a nutshell, one sentence, but it means a lot, right? So, and if you're interested in a more pictorial way, how we represent ourselves. So what we have in mind is that develop tools that we provide to people in a synthesis lab or in experimental characterization or theory, such that the data that are produced are very easily stored and processed. So this could be or should be at the end a federated data infrastructure. Then all the most important data, in particular the metadata, are then collected in the central metadata storage or service, which is, of course, somehow part of the NFTI. And this is what looks like public viewing. These are us, these are the scientists, but these are also people from outside, like from industry, from, well, the interested public or so. They all can then operate and see and look up, search for all the data that have been created in very different contexts together. So if you ask the question whether this is doable at all, because our field is so horribly complex, we were always striving for synergies. And so we identified a few topics that are somehow common to all of us. So basically everyone needs a sample, a calculation, an experimental characterization, but all of them need metadata, ontologies, workflows. So all the data need to be described, because otherwise fairness is simply a task that is impossible. All of us deal with the 4V challenges, but in very different, well, very differently in terms of volume, in terms of velocity and things like that. All of us needs these parsers, normalizers, and converters. This is extremely important to keep the community on board, because if you forbid someone to use the beloved electronic lab notebook or code, so this wouldn't work. So we need to make sure that data can be converted into each other. And this is what the success story actually of the first NOMAD initiative was. Data curation and quality assessment is getting more and more important, and we have to come up with a scheme how to tell people what data can be used for. So not to tell people data are bad, but what data can be valuable for or used for. This is also an important concept. Yeah, and finally, of course, you want to provide a visual representation. This is about the encyclopedia. This concerns to all data, but of course, artificial intelligence tools that are important or will be more and more important for all these areas that we are serving. So just in a nutshell, you will hear later more about the different areas. So just tell you in a nutshell what each area is about. I start with the synthesis here. So the problem to start with is that there is no really comprehensible source of synthesis data or recipes also. And that's why we go along 4 different synthesize routes, and the overall idea to make synthesis reproducible. This is a very, very challenging goal. And in order to go there, we started to create a reference database for crystal growth. We want to bring together the data and metadata from synthesis and experiment, because one builds on top of each other. But we also want to bring together synthesis and theory, because you also may want to use theoretical concept simulations and artificial intelligence towards growth concepts. Area B is about experiments. And of course, we know there are many, many ways to look, many different techniques to look into one sample. And these techniques are very different, because some of them give you idea about the structure, others on the electronic properties, others on the optical excitations, and so on and so forth. And we actually started with 5 different examples, which are very different in nature because each of them has their specific challenges regarding processing and data volume and so on. So they're very different in nature, such that we capture basically all kinds of, let's say, things that may pop up. But in general, we want to provide metadata for all these extremely diverse characterization methods. But moreover, since I mentioned before, we want to support the community with tools. We want to support the community particularly with electronic lab notebooks and laboratory information management systems, such to make life in the labs easier. Area C, theory and computation. So I have talked already about the NOMAD database and infrastructure. So if you look how much this is in terms of the total thing that we want to do, because you may ask, well, everything is done, right? So this is just this tiny little fraction of the overall goals that we have in mind and in front of us. So we are extending also this. It means there's a huge variety of methods. So far, we have been focusing on density functional theory, electronic structure theory. But of course, there's all these classical simulation tools, which are highly voluminous. And there is this very highly sophisticated many-body techniques, for instance, to describe spectroscopy. So we want to capture all of them and want to enhance, of course, the services that we have already, include all different levels, hierarchical levels of calculation techniques, such that we can then pass over to the engineering consortia. Area D, of course, this is the infrastructure that we built for all this. So, and I just list a few things here. It should be federated, as I mentioned. We have, well, to talk about, to think about authentication things. We have to think about security, curation, the access to via this FAIRmat portal. This is this public viewing that I've shown already. But very important is what we call the NOMAD Oasis, because the Oasis is basically the same infrastructure like the central infrastructure, but it's a standalone tool that can work inside a certain lab or in a research group or inside the university. And this could form actually a building block of this overall federated data infrastructure. Yeah, area E, use case demonstrator, is also very important, because whatever we develop, we need to make sure that this is also used by the community. Otherwise, it would be millions of euros that are spent in vain. So this area actually provides us feedback about whether these tools that we develop are really useful in the daily life of the scientists. So they're testing and giving us feedback and suggesting improvements. And they also somehow interface also with other consortia. So there's handshakes between neighboring consortia, and use cases are a good way of collaborating with them. Yeah, area F, user support, training and outreach. Again, very important for us, because whatever we develop, we need to make sure that it reaches the community we have developed it for. We don't do it for ourselves. So we have to inform, involve, embrace the community. And so actually, I forgot to mention that the topics are in the upper right corner. You always see the area leaders who are responsible for the overall work here. So, and just to cite Martin Eschlimann, we also have to somehow to convince the decision makers to stay on board, not only the students in the labs. I think they're easily to convince. So in that sense, we organize a lot of tutorials, schools, hackathons, and so on. So of course, due to COVID last year, we couldn't probably reach out as much as we wanted in the very beginning, but we will do so. Instead, we organized quite a few tutorials. We work closely together with the DPG, in particular towards a white paper on how to establish research data management in the physics curricula. And this is also a handshake with other NFTI consortia here. So just to give you a few examples, we have tutorials that are already online on the YouTube channel, on the repository, on AI, on the Oasis, on the encyclopedia, and we have also organized workshops and conferences. Many of these presentations are also available in the NOMAD NOMAD YouTube channel. So finally, area G, I think this is not too much to talk about, but one thing I would like to mention, namely that most of the developers, not everyone, but most of the developers are sitting here in the NOMAD FAIRmat headquarters at the Humboldt University, because again, as I said before, we like to exploit synergies, and having people working very closely to each other, I think this is the best possible way how to exploit synergies. Because we have to hire people with different skill sets, and they have to bring together expertise in order to build the overall infrastructure. So that's pretty much it. Such to end with, I think this last thing, we have launched a new web page. We're still in the process of adding more and more information, but you can also already look it up. You can subscribe. You will find everything about events, about the team, about the people who are there, and how we reach out to the community. With this, I'm very happy to answer questions, and thank you very much for your attention.
Thank you. Thank you, Claudia, for this introduction for our meeting here.